Uh, this is the fourth lecture of second order differential equation. So there are already we discussed about two methods to solve the second order differential equation. d2y by dx square plus p dy by dx plus qy is equal to r. The first method is when one integral is known. The second method is by changing dependent variable or by removal of first derivative, and this is the last method, change of independent variable. So x is independent variable, change independent variable x to z with proper substitution, also remove the first derivative here, and we solve this differential equation. So what is the method to solve the second order differential equation? d2y by dx square plus p dy by dx plus qy is equal to r by changing independent variable. Okay, so we now discuss what is this method here. So this is the d2y by dx square plus p dy by dx plus qy is equal to r with the second order differential equation. Let us change the independent variable x to z. We change here x variable by the variable z. So what is the relation between x and z? By the relation z is equal to fx. So z is equal to fx. So we find this relation. In this theory. So what is z? So this is fx. But what is fx? So we have to find here. If we put this, we get the equation this here. Okay. So now dy by dx. So how we can write here dy by dx? So what dy by dx is dy by dz into dz by dx. So dz get cancelled. This is the dy by dx. So dy by dx is dy by dz into dz by dx. Again we differentiate dy by dx with respect to x. So this is d2y by dx square. Okay, means dy by dx of dy by dx. So derivative of dy by dx. So this is again d2y by dx square. What is the dy by dx? So put dy by dx is this value in this here. Put dy by dx is equal to this dy by dz into dz by dx. Then find the derivative of this with respect to x by product rule. So then what is the derivative? So derivative of this d by dx of dy by dz and dz by dx as it is plus dy by dz as it is, then derivative of this dy by dz as it is, then derivative of this, so d by dx of dz by dx. Okay, then what is the next step? So we write this operator d by dx in terms of d by dz. So how we can write that? So that is d by dx is dz by d by dz into dz by dx. Means dz cancel, d by dx is this here. Okay, so dy by dz as it is and dz by dx as it is. So this operator can be written as d by dx can be written as d by dz and dz by dx. So of dy by dz and dz by dx as it is. Okay, then dy by dz. Okay, so what is the derivative of this d by dx of dz by dx? So this is the d2z by dx square. So this is equal to what is this? d2y by dz square. Okay, dz by dx into dz by dx. So dz by dx bracket square plus, so dy by dz as it is. So this is as it is. So we get here d2y by dx square is this. Okay. Therefore, putting these values, this value and this value in this equation. Therefore, the equation becomes here. What happened? So putting this value here. So what is d2y by dx square? This value putting here. So we get this plus p. What is dy by dx? dy by dx is dy by dz into dz by dx. Okay, this is putting this value in this equation, so we get this. So plus qy as it is r. Okay, so now we write this equation. So dz by dx bracket square right here and this right here. Okay, so common out from this dy by dz. Okay, so that is p dz by dx, and dy by dz common out, so this is d2z by dx square. Okay, plus qy as it is equal to r. Okay, so this is equation number 2, this is equation number 1 here. Okay, so then so what happened here? So this equation we get, say equation 2. So this equation can be written in the form d2y by dz square. So we divide this equation by this throughout. We divide this equation by dz by dx bracket square. We get this equation. So okay, what is p1? So dividing this to this equation, so this is get cancelled here, so this is as it is. Then what is p1? P1 is this divided by this, so right here. Then what is q1? Q divided by this, so that is q1. Okay, what is r1? R divided by this, so this is r1. So the given equation, after substitution of this, we get this differential equation. Okay, this is differential equation. This differential equation is 2 here. 2. Okay, then so for our convenience, we choose z. Such that p1 is equal to 0. So we find here z. What is z in terms of x? So for that, we put p1 is equal to 0. Means this term remove here. Again this term remove. So put p1 is equal to 0. So this is 0. So this is equal to 0. Then what happened? So this is equal to 0. So denominator get get right hand side. So this is 0. So this equal to this. P1 is equal to 0 implies that. So P1 is equal to 0 implies that d2z by dx square plus p dz by dx is equal to 0 here. Okay. So this can be written as d by dx of dz by dx plus p dz by dx as it is. We write the equation in this form. Putting dz by du is equal to u. So this is u. Put dz by dx is equal to u. So putting this equation becomes, so put this is u. So this is du by dx, du by dx plus p dz. So what is this? Du by dx plus p dz by dx is equal to 0. Then separate the variables. What happened? This is u here. Du by. So that is du by dx. Okay. And then by separating the variables, what happened here? So this is du upon u minus p dx. P, just what happened here? We write again here. So what happened? So this is put dz by dx is equal to u, means what happened here? So this is du by dx plus p dz by dx is u is equal to 0. Okay, so then variable separable type du upon u p dx, that is minus p dx. Okay, so on integration of this is log u, so this is minus integration of p dx. Okay, so log u is this, so u is equal to e raised to minus integration of p dx. Okay, so therefore again we integrate this differential. Put u is equal to d z by dx. U is equal to d z by dx. So we get this. So again we integrate this equation. Integration of dz is z, and integration of this is integration of e raised to minus p dx dx. So this is z. So this is z. So f of x is this here. F of x. This is very important. This is very important. Okay, for solving the differential equation. Okay. So z is equal to integration of e raised to minus p dx dx. Okay. So that is f of x. With this substitution in this equation, we change the independent variable x in terms of z. With this substitution, the equation 2 becomes d2y by dz square with this substitution, d2y by dz square. P1 is 0. So this term get cancelled. So Q1y is equal to R1. So this is equation number 4 here. This is equation number 4. Where P1 is 0 here. P1 is 0. We take P1 is equal to 0 and obtain z in terms of x. So this is a restriction. And P1 is equal to 0, then automatically the term, first order term, get cancelled. And the equation becomes very simple differential equation. We can solve easily. So that is the d2y by dz square plus q1y is equal to r1. Where q1 is what? Q upon dz by dx bracket square. And what is R1? Is R upon dz by dx bracket square. So this is the very simple differential equation in the type linear differential equation with constant coefficient. So this is linear differential equation with constant coefficient. And we can solve this differential equation very easily. First we find out the complementary function, and then we find out particular integral. Then what is the complete solution is what? So the y is equal to CF plus PI. Then we get the solution. Again we resubstitute z is equal to something function of x. In that solution we get the final solution of this differential equation. So this is the method to find here the solution of the second order differential equation d2y by dx square plus p dy by dx plus qy is equal to r by changing independent variable x to z. So we remember here only, so this differential equation, this is this, and remember the value of q1, r1 and this formula. So it is, so see here, so you remember what is z to solve a differential equation. Example, you remember that. You remember this equation. What is q1 and what is r1? Those things you remember, then you can solve the example easily, no doubt. So we take an example here. Solve the differential equation. Example, solve d2y by dx square minus cot x dy by dx plus sin square x into y is equal to 0. Okay. So solve this differential equation by changing the independent variable x. Okay. So solution. We compare this differential equation with standard equation d2y by dx square plus p dy by dx plus qy is equal to R. We have. So we get the values of P. What is P? Compare this differential equation with this. So P is what? P is equal to minus cot x. Okay, what is Q? Q is equal to sine square x. What is R? R is equal to 0 here. Okay, so we, after comparing, we find the values of P, Q and R. We change the independent variable. The independent variable x to z through the substitution. What is the formula here? So that is z is equal to integration of e raised to minus integration of p dx. Okay, so this is a very important formula. Okay, so substitution here. So what is the integration of e raised to minus, what is p? P is minus cot x dx. So this is what? Cot x dx into dx. So what is the integration of this? Integration of this is what? E raised to integration of cot x is what? So this is a log of sin x. So this is a log of sin x. Log of sin x dx. So integration of cot x is a log of sin x. So this is equal to, what is the e raised to log of sin x? Is simply sin x dx. What is the integration of sin x? So this is minus cos x. So therefore z is equal to minus cos x. Okay, so this is very important. Z is equal to minus cos x. So then what is the dz by dx? The derivative of this, dz by dx. Okay, dz by dx is the derivative of this. Derivative of cos x with respect to x, that is a minus sin x, minus plus. So this is a sin x. Sin x. So what happened here? So with this substitution, put z is equal to minus cos x in this equation. With this substitution, so this is equation number 1. With this substitution, the equation 1, with this substitution, the equation 1, so this equation 1 reduces to becomes, so what happened here? So this equation becomes here. So by using theory, just we explain what is the theory to find the solution of the second order differential equation by changing independent variable. So equation 1 becomes, so this is a d2y by dx square plus p1, no, d2y by dz, we change our variable, d2y by dz square, we change independent variable x to z. So d2y by dz square plus p1 dy by dz plus q1 y is equal to r1. Okay, so we change here independent variable x, and in terms of variable z, through this substitution we get this equation. So in this equation, so you remember what is the p1? P1 is 0. We take p1 is equal to 0, and taking p1 is equal to 0, we obtain this in the theory. Okay, then what is the q1? Q1 is what? Q upon dz by dx. Remember this formula. Q upon dz by dx bracket square. What is Q? Q is what? Q is Sine square x divided by, what is dz by dx? So dz by dx is sine x. Z is equal to this. So dz by dx is sine x. So dz by dx bracket square means sine square x. So sine square x divided by sine square is 1. So q1 is 1. This q1 is 1. So similarly, what is r1? So this is r upon dz by dx bracket square. But what is r? So r is 0 there. So 0 upon dz by dx means sine square x. So that is 0, 0. So with this substitution, the equation, this is equation number something 2 here. Equation 2. Equation 2 becomes. So what is this? d2y by dz square plus p1 is equal to 0. No doubt. So that is q1. What is q1? q1 is 1. q1 is 1. So plus y is equal to 0. And this is a very simple differential equation. So this is a linear differential equation with constant coefficient. So this is linear differential equation with constant coefficient. So this is very simple. So by using operator d, capital D is equal to d by dz. D by dz. So this equation can be written as, so d square plus 1 y is equal to 0. Okay. So this is a linear differential equation with constant coefficient. So how to solve this differential equation? For that, the auxiliary equation is what happened? So this is d square plus 1 is equal to 0. So that is d square minus 1. So what is minus 1? Minus 1 is I square. I square is minus 1. I square. So what are the roots of that equation? Roots of that equation, second degree equation. It has two roots. So what is d? D is equal to I taking square root plus or minus I. So this is minus I. So these are the complex roots here. So are imaginary roots in the form alpha plus I beta and alpha minus I beta. Okay, I beta. So what is alpha? So alpha plus I beta means 0 plus I, and this is 0 minus I. So alpha is what? This can be written as this. Alpha is 0, beta is coefficient of I, so beta is 1. So okay. So what is the solution? Therefore the solution is CF is the solution. Therefore this CF is the solution. Is the solution. What happened? Complementary function is the solution of this differential equation. So therefore y is equal to, what is the solution here? So that is C1, standard solution is what? C1 e raised to a z, m1z. No. So just what happened here? So roots are complex. Then what are the solution here? So e raised to alpha z, then C1 cos z, cos beta z plus C2 sin beta z. Okay. So when the roots are complex, then complementary function is this. So we solve many examples when the roots are complex, then what is the complementary function? So this equal to, what is alpha? Alpha is 0. E raised to 0. So that is 1. So this is C1. Y is equal to cos of what? What is beta? Beta, I beta, coefficient of I, 1. Beta is 1. So cos z. Beta is 1 here. So again beta is 1 plus C2 sin z. Okay. So then resubstitute. Resubstitute. What is z? Z is equal to what? Minus cos x. So we get here. So y is equal to C1. Put z is equal to minus cos x. So cos of minus cos x plus C2 sin of, put z is equal to minus cos x minus cos x. Okay. Therefore, so y is equal to cos of minus theta is cos theta. So this is C1 cos of C1 cos of cos x. What is sine of minus theta? Is minus sine theta. So minus C2 sine of cos x. So this is the required solution of this differential equation, final solution. So what we have to do here, so we compare this equation with this, then P, Q, R we get here. So we change the independent variable x to z through the substitution. Z is equal to f of x. F of x means z is equal to, what is f of x? Integration of e raised to minus integration of p dx. Okay, put p is equal to here, p. What is p? P is minus cot x. Then find the integral of this. So that is e raised to log of sin x. So we get this is sin x. Again we find here. So integration of sin x is minus cos x. So z is equal to minus cos x. Okay. So this is the z in terms of x. So because we change here independent variable x in terms of z, so we get this relation. So obtain dz by dx. So that is sin x. Okay. So with this substitution, this equation becomes like that. So we study in the theory. Okay. So d2y by dz square plus p1 dy by dz plus q1y is equal to r1. But we take p1 is equal to 0. Taking p1 is equal to 0, we obtain this in this theory. Okay. So p1 0, q1 is q upon dz by dx bracket square. Okay. So what is q? Q is sin square x. What is it? dz by dx is sin x. Okay. Sin square x is 1. What is r1? R is 0. So this is 0. Therefore this equation becomes d2y by dz square, p1 0, q1 is 1, r1 is 0. So this equation can be written like that. So the auxiliary equation is this. Roots are I minus 1, I minus I. Then its complementary function nothing but a solution. So this is the solution. Resubstitute z is equal to minus cos x. We get the final solution. So this is the method of solving the second order differential equation by changing independent variable x. So we remember we remember this formula. Z is equal to integration of e raised to minus integration of p dx. This equation and what is q1 and what is r1. If we remember that, you can easily solve that example. Okay, thank you.